Hello and welcome. In this video, we're going to talk about moment of a force. Let's start right now. So if you sit on a seesaw, you're going to see that your weight, which is a force, is going to push down on one side of the seesaw, and the seesaw is going to turn. It's going to turn about this point. We call that a pivot. So you put a force on one side and it turns it. Now the ability of a force to turn an object about a point is called the moment. A moment. Now we see moment all the time in our lives. Example is when we turn the wrench. We use a force which will turn the wrench about this point. Or when we turn the doorknob, we use moment. Now, how do we find the moment? Moment is the force that we use times the perpendicular distance from the force. Again, moment is what? The force that we use times the perpendicular distance from the force. So in this example, the force is what? 700 newtons, and the perpendicular distance, okay, the distance that makes 90 degrees with the force is 2 meters. Okay, now let's look at some examples. The first example is this. We have a bar and we put 40 newtons on one side of the bar, and the force is 2 meters away from the pivot. What is the moment? So we have to find the moment. It is what? The force times the distance, which is equal to 40 newtons times 2 meters, and the answer will be 80 newton meters. What about number 2? So number 2, we have two forces on one side, 50 newtons, 10 newtons, and here are their perpendicular distances. So what is the moment? It is what? The force times the perpendicular distance. Okay, this is the word, perpendicular. So that will be the first moment. We have to find the moment for the 10 Newton force and add together with the moment of the 50 Newton force. So the moment of the 10 newtons will be what? 10 newtons times 1 meter plus 50 newtons times 2 meters. This is going to give us about 110 newton meters. This is the moment. Let's look at another example. So here we have forces on the left side and the right side, and we have to find the net moment, okay, the total moment. Now if you look at it, the 100 newtons force is going to push the bar anti-clockwise, in an anti-clockwise direction. So it is going to create an anti-clockwise moment, okay? But these two forces will create clockwise moments. They will turn the bar in the clockwise direction. Now we like to write the anti-clockwise moment as positive and the clockwise as negative. So let's try and find the net moment. We have to find the anti-clockwise moment and then add together with the clockwise moment. So let's try and find that. So anti-clockwise moment, we have 100 newtons times 2 meters. This is going to give us 200 newton meters, which is positive, right? It's anti-clockwise. What about the clockwise? So in the clockwise moment, we're going to have, we have to calculate or find the moment for each of the forces. So we have 150 newtons times 1 meter. We bring the negative sign because it is what? Clockwise. And we add to the 25 newtons times 2 meters. Again, we bring the negative sign to show that it is clockwise. And the final answer is going to be, we're going to have 1 minus 150 Newton meters minus 50 Newton meters, which is minus 200 Newton meters. Again, the minus sign shows that, this sign shows that it is what? Clockwise. The moment is going the clockwise direction. Now, what is the net moment, the total? We have to add the anti-clockwise together with the clockwise. And that is going to be 200 Newton meters plus minus 200 Newton meters. And the answer is 0. So if the moment is 0, it means the bar does not move. It is balanced. Okay, it is balanced. Let's look at another example. We have two friends, Lee and Joe. Playing the seesaw. Lee is pushing down with a force of 500 newtons, and the distance, the perpendicular distance, is 3 Newton meters. 3 meters. Okay. Next is Joe. Joe is sitting 6 meters away, but we don't know how much force Joe is using. And the question is, how much is Joe's weight if the bar is balanced? The bar is balanced, it's not moving. So let's try and find the answer here. So we know that Lee is going to create anti-clockwise moment, Joe will create clockwise moment. And because the bar is balanced, the anti-clockwise moment will be equal to the clockwise moment. It will be the same. So let's try and find that. So anti-clockwise moment will be 500 times 3. And this should be equal to the F, we don't know F, times the distance, 6 meters. And we bring the negative sign to show that it is clockwise. So if you write it again, we should have the anti-clockwise moment is 1,500 Newton meters. And we can write it again to be minus 6 meters times F. So what is F? F is going to be 1,500 over minus 6, which is going to be minus 250 newtons. But this is force, right? And force should not be in negative. So Joe's weight will be about 250 positive, okay, because it's a force. Now let's continue and look at a more difficult question. So I have a bar and I put a force of 30 newtons about 3 meters away from the pivot, and my force makes an angle theta. So what is the moment of my force? Now we said moment is what? Force times the perpendicular distance, right? But now we can see that the distance is not perpendicular to the force. So the force is at an angle. Now this is a problem. We have to find a force that is not at an angle like this, but perpendicular, 90 degrees from the bar. How do we find that? So first, if you have a force at an angle like this, a theta, we can divide the force into two, a vertical force and a horizontal force, like something like this. So we can divide this force F into what? The vertical and the horizontal part, into two parts. So if we can find this one, the force here, we can use it to find the moment. Okay, now again, this will make what? A right angle triangle. So let's call this as A and B. We don't know this part, but if we can find it, we can use it because it is perpendicular to the bar. Now you can see that it has formed a right angle triangle. This is 90 degrees. And in right angle triangle, we have a way to find the sides A and B. The sine of theta, sine theta, is equal to the opposite of theta. What is the opposite of theta? A, over the hypotenuse. The hypotenuse is this part, okay? The F. So sine theta is equal to A, the opposite of theta, over hypotenuse, which is the F. So sine theta is what? A over F. So, but we want to find this force, right? The A. So what is A? A will be F sine theta. F sine theta. Now we can go back to our formula. Moment is force times distance. So what is our force? It is not the F, because F is what? Not perpendicular. It is the A. So A is what? F sine theta times the distance, which is what? 3. So let's look at another example. So this will be our formula now, right? F sine theta times D, which is 3. Let's look at this example to help us understand. So let's say the theta is 60, okay? And I put a force of 30 newtons. So first we have to find A, right? The force which is perpendicular to the bar. So A is what? We put in sine theta is what? Opposite over hypotenuse. The opposite is A. The theta is 60. And the hypotenuse is what? F, the force, which is 30. So we have sine 60 is equal to A over 30. So what is A? A is 30 sine 60 degrees. And the answer should be about 25.98 newtons. Okay. Let's go and find the moment. The moment is what? Force times distance. And the force we're going to use is the A, not the F, because F is not perpendicular. Okay, we want the perpendicular force. So that is A. So moment is what? The force, F sine theta times D. What is F sine theta? Is here, is the A. 25.98 newtons times D. And the answer will be 77.9 Newton meters. Okay, so this is our example. I hope this is helpful. Thank you very much for watching.